Hello everyone. Today we will discuss the chemistry chapter regarding 12th standard, that is haloalkanes and haloarenes. So this chapter consists of two parts. One is haloalkanes and the other is haloarenes. Now we should discuss about these two topics detailedly one by one. Initially, haloalkanes. Right. What are these haloalkanes? In the name itself, there is alkanes, so that we can say that these are derived from alkanes. So the compounds derived from alkanes by the replacement of one or more hydrogens by the corresponding number of halogen atoms. So already we know what are these halogens: fluorine, chlorine, bromine, iodine. So all these are called halogen atoms. If we replace hydrogens with the required number of halogens in alkanes, then they are termed as haloalkanes. Right. So the definition for haloalkanes is compounds derived from alkanes by the replacement of one or more hydrogens by the corresponding number of halogen atoms. They are termed as haloalkanes. Now, how to write the general formula of haloalkanes? Already we know the general formula of alkanes is CnH2n plus 2. So that the number of hydrogens in alkanes is 2n plus 2 hydrogens, if n is the number of carbon atoms. So in this formula, if we replace at least one hydrogen with the corresponding number of halogens, then that becomes the general formula for haloalkanes. For example, now I will replace one hydrogen. If we remove one hydrogen, so that the formula becomes CnH2n plus 1, and in place of hydrogen I will write X. Then that is the general formula for haloalkanes: CnH2n plus 1 X, where X is any halogen atom and CnH2n plus 1 is hydrocarbon part. Or it is also written as simply it is Rx. Rx is also the general formula for haloalkanes, where X is any halogen and R is alkyl group or hydrocarbon part. Examples for haloalkanes. Now let me write the formula of methane here. Methane is CH4. Now according to the definition, we should replace these hydrogens with the required number of halogens. If I remove one hydrogen and in place of hydrogen if I write chlorine, it becomes CH3Cl. This is an example for haloalkane. Similarly, we can write CH3, CH2, Br, CH3, CH2, CH2, Br, etc. So like this, we can give the examples for haloalkanes. Now this is the general introduction, a very simple introduction for haloalkanes. Right, then we'll move to the classification of haloalkanes. Classification of haloalkanes. The haloalkanes can be classified on different aspects here. Among those, based on number of halogen atoms present, they are classified as monohalogen derivatives, dihalogen derivatives, trihalogen derivatives. So we will discuss one by one here. That is, the first one is monohalogen derivatives. Now what are monohalogen derivatives here? So in these compounds, the number of halogen atoms will be only one. So in the name itself, mono means only one. So one halogen containing haloalkanes or monohalogen derivatives. So just now we have discussed the examples here: CH3Cl, CH3CH2Br, etc. All these can be examples for monohalogen derivatives. Then dihalogen derivatives. Dihalogen derivatives means in the name itself, these contain two halogen atoms. Based on the position of halogen atoms here. The position means on which carbon atoms the halogens present. So based on that, these are once again classified as geminal dihalides, vicinal dihalides, or alpha, omega, or terminal dihalides. We can call this as terminal dihalides. Now, what is a gem dihalide or geminal dihalide? So, geminal dihalide or gem dihalide means in those compounds or in those dihalogen compounds, both the halogen atoms will be present on only one carbon atom or on the same carbon atom. If the two halogen atoms are present on same carbon atom, then that is an example for gem dihalide or geminal dihalide. And what are vicinal dihalides? If the halogen atoms are present on adjacent carbon atoms, see here, adjacent carbon atoms. Adjacent means side by side. The carbon atoms which lie side by side to each other. Such carbon atoms are called adjacent carbon atoms. If the halogens are present on adjacent carbon atoms, then they are called vicinal dihalides. Similarly, if those halogen atoms are present on the first carbon and on the last carbon of the parent chain, that means end carbon atoms. Usually end carbon atoms are called terminal carbon atoms. So if the halogen atoms are present on end carbon atoms, then they are called terminal dihalides. So this is about dihalogen derivatives. And then coming to the trihalogen derivatives, we can clearly, it is very clear in the name itself, tri means three halogens. If the compound contains three halogen atoms, that is considered as trihalogen derivatives. So like this, based on number of halogen atoms, we can classify haloalkanes as monohalogen derivatives, dihalogen derivatives, and trihalogen derivatives. Similarly, we can classify these haloalkanes on different aspects, like the type of carbon atom to which the halogen is attached, and the type of hybridization of carbon to which the halogen is attached. So that we will discuss in the next class. Thank you.